Today, students, so in this clip, we're going to be going over a special number known as the golden ratio. So basically, what is the golden ratio and how do we derive the result? So basically, what we're going to be doing first is I'll show you how the golden ratio comes about. So let's say we have a segment like this. We make it a blue segment and a black segment. Make it black segment like that. Um, so let's say we have something like this. And what I'm going to do is I'm going to partition this segment. Let's partition this segment down here. So let's call this portion right here, from here to here. We can call it A, and this portion from here to here, B. The golden ratio is a special ratio where if the ratio of the sum of the sides to the longest side is equal to the ratio of the longer side to the shorter side. So the golden ratio basically is if the sum of the sides a plus b, which is the whole thing, divided by the longer side a, if this ratio is equal to the ratio of the longer side, which is a, over b. All right, so this is known as the golden ratio, and the symbol that's used to represent the golden ratio is the Greek alphabet P. Okay, phi. All right, so there goes the golden ratio, and phi has the has the irrational expression 1 plus root 5 over 2. Okay, and that's approximately 1.61803398, and then it goes on and on. So it's an irrational number. Okay, so there you have it. This is the line segment form of the golden ratio. Um, so this is line segment, and this right here is the golden ratio. All right. All right. You also have the golden ratio in the context of a rectangle. In that case, is known as a golden rectangle. So, what on earth is a golden rectangle? If I have a square and a rectangle in the following proportions, so let's say I have a square like this, and then I have a rectangle like that. Okay. So this is a square. Let me just move my rectangle a little bit right there. So, if I have the dimensions of my square as follows, a little bit up so that it fits perfectly. So if I have the dimensions of my rectangle, let's say this is A and A, and obviously this is going to be A2, right? And if this is B right here, now these two sides are in the same proportion, in the same ratio as this side right here, and this rectangle right here is going to be known as the golden rectangle. This is basically known as the golden rectangle right here. Okay, so this is a special relationship. If we have a plus b, a plus b, which is the whole thing. This is a plus b right here from here to here. It's a plus b. If a plus b divided by the longer side, which is a, is equal to the ratio of the longer side a over b, then we have here a golden rectangle, and that is also equal to phi, which is a good alphabet. Okay. All right. So there you have. This is all known as a golden rectangle. Okay. Okay. So basically, in the context of this golden rectangle, this right here, this is the length. Or we can call this the width, and this is the length. So if the ratio of the length to the width is phi, then we have a golden rectangle. So any rectangle where the ratio of the length and the width are in this proportion, then we have a golden rectangle. Okay. So basically, this ratio is going to be length of the width is going to be 1.618. That's going to be the ratio. All right. Okay, and also the golden a ratio can also be applied to circles too. Let's say we have a circle like this, okay, and we can segment portions of the circle. Let's say this is the center of the circle right here. All right. If the circle is divided into two arcs in a special proportion, let's say this is B and this is A. If we have the proportion A plus B, which is the circumference of the full circle, the ratio of the circumference of the full circle to the longer side, if that is equal to the ratio of the longer side to, I'm sorry, so if the ratio of the circumference of the whole circle to the longer side is equal to the ratio of the longer side to the shorter side, we have a golden ratio here also. Okay, this is also a golden ratio. Well, in this context, this angle right here, this angle, let me call it, let's see, this angle right here, okay, and it's also important to know that this angle right here, let me just call it theta. Theta is known as the golden. It's called the golden angle. Okay, known as the golden angle. So the ratio of this side, this arc length right here to this arc length is in this special relationship, then it's known as, this angle formulates something known as a golden golden angle. Okay, and the golden angle is approximately about 137.508 degrees. Okay. All right. So with that in mind, let me show you how to come up with this whole golden ratio business. So we know I showed you what the golden ratio is earlier. It's about 1.618. So phi is basically the golden ratio. Phi is basically 1.618, and then it basically goes on and on and on. That's the approximate value, 1.618,033. So it's approximately well, it's equal to 1 plus root 5 over 2, which is approximately 1.6183, and then it goes on and on and on. All right. So how do we come up with this number? So I'm going to show you how to derive this golden ratio value, the exact value of the golden ratio. You can use your calculators to then find what the approximate value is. So let's do this. So what I'm going to do is I'm going to create a segment, and I'm going to dissect the segment using the proportional rules or relationship of the golden ratio. So I'm going to say let this whole segment have the length x, okay, and then let this portion right here be 1 unit long, okay. So if the whole thing is x and this portion is 1 unit long, then what you have left is basically this piece minus that piece right there. So this piece here is going to be x minus 1, okay. So there you have it. All right, so let me just make my my indication more obvious. I'll move this down a little bit. Get that, see that over there. So what I just did is I just dissected my segment. The whole thing is x, and then we have this piece right here and that piece right there divided into x and x plus 1. So what I'm going to do is I'm going to establish the golden ratio, and then I'm going to show you how this whole result came about. So from here to here is 1, and then from here to here is x minus 1, because x minus 1 is just this. All right. So for this segment, the golden ratio says that the ratio of the sum of the two sides, which is x, to the longest side, which is 1, because this side is obviously longer than that side, is equal to the ratio of the longer side, which is 1, over the shorter side, which is x minus 1. All right, so if I solve this, then we'll be able to know what the golden ratio is. All right, so let me put it over here, and then I'm going to proceed to solve it. All right. Okay, so how do we do this? So to do this, what I'll do is x minus 1. I'm going to start out by cross multiplying. When I cross multiply, I'm going to have x squared minus x equals 1. Subtract 1 from both sides, and then you're going to end up with x squared minus x minus 1 equals 0. Alright, so there are different ways you can solve this. This one cannot be solved by factoring because it's prime, so I can either use the quadratic formula or completing the square. So I want to use the completing the square method here. So let's solve this by completing the square. Okay. Alright, so to do this, what I'm going to do, I'm going to, first of all, I need these two terms isolated. So since this is not a perfect square trinomial yet, so I'm going to add 1 to both sides. I'm going to have x squared minus x equals 1. To complete the square, we basically add b over 2 squared to both sides. So in this case, b is negative 1. What do I do with that? I divide it by 2. And then I square it, which gives me 1/4. Okay? So I'm going to add 1/4 to both sides. So I'm going to have x squared minus x plus 1/4 equals 1 plus, add that 1/4 again. Okay? Alright, now what have I just created on the left side? I've just created a perfect square trinomial. So how do I factor this? I just read the first term and the last term, and then I bring down the middle sign. Alright? So you're going to have x minus 1/2 quantity squared equals 1 plus 1/4. 1 plus 1/4 is just, you can make this 1 times it by 4 top and bottom. We have 4 over 4 plus 1 over 4, which equals 5/4. Okay? Equals 5 over 4. Now, how do I solve this equation? You can take the square root of both sides. So I take the square root of this side and the square root of that side right there. So on the left side, I'm going to end up with the absolute value. Wrong color. I'm going to end up with the absolute value of x minus 1/2. Because anytime you take the square root of a square, you end up with the absolute value equals. I break the square root to the top and bottom. Square root of 5 divided by the square root of 4 is just 2. Okay? Now, another way of expressing absolute value is the distance from 0 left or right. So going to the left is negative, going to the right is positive. So I'm going to write this as plus or minus. Plus or minus, this is what absolute value means. Minus to the left, positive to the right. X minus 1/2 equals root 5 over 2. And then divide both sides by plus or minus. Divide both sides by plus or minus. And then you're going to end up with the plus or minus basically moving over to the other side. So x minus 1/2 equals plus or minus root 5 over 2. Okay, we're solving two equations simultaneously. That's why we have it looking like this. Alright, so next, what we're going to do is basically move this 1/2 to the right side. We can just write it as x minus 1/2 equals plus or minus root 5 over 2, since the minus is gone. So we're going to add 1/2 to both sides. Add 1/2, add 1/2. Oops, no. And add 1/2. And then you're going to have x equals 1/2 plus or minus the square root of 5 over 2. Okay? So when I combine them, I'm going to have x equals 1 minus root 5, plus or minus root 5 over 2. Alright? So since the golden ratio is a positive number, is a length, we're going to drop the negative component. So because our solutions are x equals 1 minus root 5 over 2 and 1 plus root 5 over 2. We're going to scrap the negative 1, okay, because the proportion is positive, so this is our result right here. So this is the golden ratio, 1 plus root 5 over 2. Alright? And if you want to find the approximate value, you can just fire up your calculators and enter that expression correctly in the calculator, and it should give you 1.618. So let's verify. So we have parentheses 1 plus root 5 divided by 2. See that? That's exactly what we want. Approximately 1.61803. and then it goes on and on. Okay, so that's how to derive your golden ratio. Okay, and this is basically what phi is. All right. So what's cool about this? This is an amazing number. It has a lot of applications. Like this right here. This is a golden rectangle, as you can see, and the pattern continues. Um, this is known as a golden spiral. If you didn't know, this is a golden spiral. Golden spiral. And you have that relationship we talked about earlier. This is A and this is B, and this is A and this is A. And we have the ratio A plus B over A. The whole thing over the longer one equals the longer one over the shorter one. Okay, and then that same pattern continues here, and you keep going. If you keep repeating that pattern into itself, and then you connect the dots, you have an amazing geometric figure known as the golden spiral. Da Vinci studied it and found out that the parts of the human body, this is the application in art, can be divvied up using the golden rectangle, the golden rectangle. Okay, you can see it here. This is a golden rectangle overlapping with another golden rectangle here, and then you have the proportion of the face and the shoulders with two golden rectangles here. You can see it. Let me just highlight one so you can see. So this is one. This is like B. I'm sorry. This is A. This is B, and this is A right here, and then that's A. So you kind of have a golden rectangle right here. Okay, and then you have another one right here. So it's kind of interesting how he found that proportional relationship. And you have the spiral showing up in so many things in nature. You have it in plants. You have it in sea creatures like a shell. You also have it in flowers too. You see the spiral there. And then another application is in architecture. A lot of solid ancient structures are divvied up, or they have this special proportional relationship using the golden ratio. I hope you can see the golden ratio in this ancient building right here. This piece right here is the A, and this is the B. So that means that the whole rectangle is going to be the measure A plus B, A plus B. So you can then, it's obvious if you do the computation, you see that if you actually measure it, you see that the relationship is actually the golden ratio, A plus B, right there. And also in architecture too, you can see the application here, how the dimensions, the components of the building are constructed. It turns out that proportioning your buildings using this ratio creates very, very solid structures. That's why you have this ancient European structure still standing today. Okay, so thanks for watching this video. You can always subscribe to my video. I'd like you to do that, and you can request videos if you want any mathematical explanation. If you need access to more clips, just go to math.serve.com and enjoy. Have a wonderful day.